Sinscript ever pondered the significant relationship between survey responses and the questions asked? Picture this: a survey conducted across various institutions in Nigeria to assess the effectiveness of integrating information and communication technology, commonly known as ICT. In the realm of statistics, we have a tool called the chi-square test, which aids in determining the correlation between different variables. We'll explore this fascinating tool today. Output. Consider a situation where we have a table of survey responses from participants. We aim to determine if there's a significant relationship between the responses and the survey questions. Step into the shoes of a statistician and hypothesize. The null hypothesis, denoted as H0, assumes that there's no significant relationship between the responses and the questions. The alternative hypothesis, H1, proposes the contrary. The first step involves arranging the observed frequencies into a contingency table format. This table will provide a visual representation of the distribution of responses to each survey question. Output. Next, we calculate the expected frequencies under the premise of no association between the responses and the questions. This involves multiplying the row total and column total and then dividing by the grand total. With these expected frequencies, we dive into the heart of the chi-square test. The chi-square statistic is calculated using the formula H2 antis S. This formula quantifies the difference between our observed and expected frequencies. Output. Now comes the exciting part. Once we have the chi-square statistic, it's time to compare it to a critical value from the chi-square distribution. The degrees of freedom determined by the number of rows and columns in our contingency table guide us in finding this critical value. If our calculated chi-square statistic surpasses the critical value, we reject the null hypothesis. This means there is a significant relationship between the responses and the survey questions. On the other hand, if the statistic falls short of the critical value, we fail to reject the null hypothesis, indicating no significant relationship. With the aid of statistical software or a chi-square table, we can obtain the critical value corresponding to our desired significance level, often chosen as 0 as 5. Upon conducting the chi-square test for each survey question, we can interpret the results and draw conclusions. In the case of our Nigerian tertiary institutions, while there is growing acknowledgement of ICT integration's importance, significant challenges persist, particularly related to infrastructure limitations and digital literacy gaps among educators and students. In summary, the chi-square test is a powerful statistical tool that allows us to test the relationship between different variables. By formulating hypotheses, constructing a contingency table, calculating expected frequencies, and comparing the chi-square statistic with a critical value, we can draw significant conclusions from our data. These insights can then inform strategies to improve ICT integration, proving the power and importance of statistical analysis.